Hi Year 9, welcome to Lesson 5 on the effect of catalysts. Right, on this slide, there are 3 questions that I want you to answer in your exercise book. So if you have a revision guide next to you, make use of the revision guide. I want you to pause the video now. Take time in answering all these questions. Right, the answers for the quick quiz are displayed on this slide over here. So the answer for activation energy is the minimum amount of energy that particles must have before they can react. The formula to work out mean rate of reaction. Remember, there are 2 formulas you can use. Quantity of reactant used, divide that over time, or quantity of product formed, divide that by time. And for question number 3, you need to use one of this formula and also the results from the table on the slide to work out the mean rate of reaction for small chips, medium chips, and for large chips. So if you look from my working, so the result for small chip is 0.0245. The unit is grams per seconds. And the result for medium chips is 0.0133 grams per seconds. And the result for large chip is 0.00850 grams per seconds. So, what is a catalyst? Catalyst is a substance that increases the rate of reaction, but it is not chemically used up during a reaction. Catalysts can be used again and again for many different types of reactions. So on this diagram over here, you can see enzyme is a type of biological catalyst that can speed up the rate of the majority of the chemical reaction that happens in our cells. They are also highly specific for one particular type of reaction. So this is mainly because of the structure of their own active sites. So you can clearly see from the diagram that maltose has got a specific shape which can correctly bind to the specific shape of the enzyme. So the active site of the enzyme will react to the specific shape of maltose and then produce 2 different types of product. In this case, this will be the glucose. So enzyme is a type of biological catalyst. Right. How do catalysts work? Catalysts provide a lower energy, alternative pathway for the reaction to happen. This means that more particles have the required activation energy to react, so the reaction rate increases. If you see the diagram above, this is the diagram of an exothermic reaction. This is an energy profile diagram. So you have the energy on the y-axis and you have the progress of reaction on the x-axis. So there are 2 different types of graph there. So you have activation energy with catalyst and also activation energy without catalyst. A reactants reacting with the presence of catalyst will have a lower activation energy. Therefore, the product can form quite easily. The reactants without a catalyst will have a higher activation energy. Therefore, it needs to overcome a higher activation energy in order to produce the product. So this is an example of an exothermic reaction. If you're not sure the meaning of exothermic and endothermic reaction, I want you to stop the video and look up for the reaction first before we proceed. For task number 1, you need to copy these statements and explain what they mean in your book. So for point number 1, you need to explain how catalysts speed up the rate of reaction without getting used up. And for point number 2, you need to explain how catalysts are specific to reactions. Again, if you have your revision guide, please make use of your revision guide to explain these 2 points in your book. Right, to sum up what we have done so far. So point number 1, catalysts lower the activation energy needed for a reaction to take place. This also reduces the energy needed to start a reaction. Less energy in means cheaper products, that means more profit for industry. So if you have your book with you, I want you to copy down these 3 points in your book. Right, now we are moving to task number 2. I want you to read the following paragraph and write down 4 positives and 4 negatives of using catalysts. Once you have done them, you can check your answers on the next slide. Now you can check your answers on these slides. For the positive points, point number 1, catalyst can speed up the rate of reaction. Not used up, so it can be used again. Only need a small amount and also save fuel costs. From negative point of view, it can be expensive. One catalyst will usually only work for a specific reaction. Remember, the enzyme is called an active site, so it can only bind to a specific shape of a substrate. It will eventually need replacing and need to be removed from product. So that is extra cost as well. Right, these slides explain how to investigate the effect of various catalysts on the decomposition of hydrogen peroxide. You can investigate the effect of different catalysts on the rate of a reaction. For example, hydrogen peroxide solution decomposing. So you got the equation there, hydrogen peroxide decomposing into water plus oxygen gas. The reaction produces oxygen gas. You can collect this in a gas syringe using the apparatus shown on the right. Alternatively, you can use an inverted measuring cylinder or burette filled with water. You can investigate the effect of many different substances on the rate of this reaction. Examples include manganese, 4-oxide, and potassium iodide. So I want you to pause the video now and think about the independent variable in this investigation. So the independent variable in this investigation is something that you are changing in your investigation. So you are changing the catalyst, so that would be manganese oxide and potassium iodide. A table of the time taken to produce a certain volume of gas can then tell you which catalyst makes the reaction go faster. So what type of graph would you use to show the results of your investigation and why? So very quickly in your book, I want you to draw the diagram and label the diagram correctly, and also write down the word equation and state the independent variable in this investigation. Right, this will be your task number 3. This table gives some example results of the volume of gas produced every 10 seconds. So on this PowerPoint, you will see a result table which represents 3 different types of catalyst used in this investigation. So you have manganese dioxide, iron, and also copper dioxide, and also the volume of gas produced every 10 seconds, which is written on the right hand side of the result table. So question number 1, you need to compare the results for the 3 catalysts and write up a conclusion based on that. And you also must plot a line graph. In order to plot a line graph, there are guidelines in bullet forms which you can follow. So volume of gas, which is in centimeter cubic, will be on the vertical axis. Time, which is in seconds, will be on the horizontal axis. And you need to plot a curve of best fit. You can use a line paper and a ruler and a pencil to do this. If you have a graph paper, that would be brilliant. If you haven't got one, that is fine. Once you have done that, I want you to write down an evaluation, which is the best catalyst for the decomposition of hydrogen peroxide, and explain your answer. So, based on your result table and also from the graph that you have plotted, manganese dioxide is the best catalyst because it produces the highest volume of oxygen more quickly. A graph of volume of oxygen against time has the steepest gradient for this catalyst. This will be the explanation for your result table and also for the graph that you have produced before this slide. Right, there are also some exam style questions for you to try on this topic. So gold is used as a catalyst in industrial processes. Gold is rare and increasingly expensive. So suggest 3 reasons why gold is still used in industrial processes. So this is a 3-mark questions. So try to attempt the question first before checking your answer on the next slide. Right, now you can compare your answers with any of the 3 following answers written on this PowerPoint. and mark your work accurately. The following will be true or false quiz. Right, you can write down your answer in your book. So quiz number 1, a catalyst is a substance that speeds up a chemical reaction but is not used up in the reaction. Write down if it's true or false. The answer is true. Quiz number 2, most of the catalysts used in industries are acids. Write down if it's false or true. The answer is false. Only transition metals are mainly used as catalysts. Quiz number 3, the decomposition of hydrogen peroxide can be speeded up by adding a catalyst. Is it true or false? The answer is true. Catalysts can become poisoned by impurities in the reaction, so they need to be replaced. Is it true or false? The answer is true. Catalysts work by increasing the number of collisions between reactant particles. Write down if it's true or false. The answer is false. They lower the energy needed to react. Catalysts are usually cheap as they are readily available. Write down if it's true or false. The answer is false. They are expensive as they are made of precious metals. And the last quiz is, there is a catalyst for every reaction. Is it true or false? The answer is false. Not every reaction has a suitable catalyst. Right, over here I have some useful links for you to look at for this topic. So use this link and take down some notes to improve your understanding on the effect of catalysts. Thank you for listening. Hi, Year 9. Over here, I'm going to show you the reaction of catalysts. So on my right hand side, over here, I've got a conical flask with hydrogen peroxide, some food coloring in there. And on my left hand side, I've got the same amount of hydrogen peroxide with some food coloring. And in both of my conical flasks, I've added some washing up liquid. So now we are going to show you a demo, a reaction with catalyst and also a reaction without catalyst. And Mr. Arrow is here to assist me with this practical.
Because these are decomposing, and we can actually test for oxygen, because a decomposition reaction, what should be happening, we think, is oxygen should be being released. So the test for oxygen, if you can remember, is to blow out a splint, and then if it is decomposing, we should be able to relight it. So we're going to both test, or I'm going to test firstly, just see whether there is actually any oxygen coming out here. So if it relights, so as you can see, it's a really, really slow reaction. It's not relighting my splint there. But if we add a little bit of a catalyst, what we should hopefully get to see is, oh, hey, there we go. And we should be able to relight my splint, but then I put it in the suds and blew it out. That's one. And then Miss, do you want to try yours as well?
Yes. I'm going to try a bit of potassium iodide in there.
And this is an exothermic reaction, so it's really, really, really hot.
And that is speeding up the chemical reaction.
Oh, there you go. Interesting as well. There we go.
You can see that oxygen is produced from this reaction. You can see the reaction that's taking place.
Almost relighting it. I'm not as good as you at this, miss.
No problem, so we can always try again. Let's go. So one more time.
Oh. Okay, so get it nice and glowing hot. Red and glowing, and then should be able to.
Yay, there you go.
Almost glowing but not relighting, but it's still showing that there is a presence of oxygen. And I mean, even mine now is still glowing hot and almost relights my splint. And it is very, very hot to the touch. So these were decomposing, so the hydrogen peroxide was decomposing and oxygen was being released, because hydrogen peroxide is H2O2. But then we've just sped up that reaction, and that is what catalysts do. They speed up the reaction. As you can see with mine, it's still going very, very well, which I'm quite happy with.
Thank you, Yanai.